Making a Stuart model steam plant, part 62. Drilling holes in the baseboard for mounting the water tank and condenser, plus making inlet and exhaust fittings for the Stuart S50 steam engine. This opening image is out of sequence. If you take a close look at the Stuart S50 in the foreground, you will see that it's a little bit different since the last time I showed it. In this first part of the video, I'm showing how I marked and drilled the holes in the baseboard for the water tank. This is the water tank you're looking at now, and also the condenser at the other side. I started off by working from right to left, and now it's left to right. These are the holes for mounting the condenser. And once again I'm using my Proxxon Micromot with a 90-degree end. I find this to be a really useful tool for making videos, because if I use a normal Micromot drill, my hand is often in the way. And also, because this is at 90 degrees to the board, it's easier to line it up to get a hole perfectly at 90 degrees to the baseboard. I like to keep my work area fairly clean. Definitely not tidy, just fairly clean. So once I'd finished drilling the holes, as I've just shown previously, I used the airline to blow all the dust away, obviously to another part of the workshop. This is the steam inlet fitting on the steam chest cover of the Stuart S50 steam engine. This part is supposed to be threaded 1/4 by 32 threads per inch, but instead it's been threaded 1/4 by 40. 1/4 by 40 is a thread often found on miniature steam locomotives. Among the parts supplied by the customer, I found this. It's a PM Research displacement lubricator, and this is also threaded 1/4 by 40. The first part of the job involves fitting a 1/4 by 40 threads per inch T-piece and seeing where it ends up when it's fully screwed into position. Brass is notoriously difficult to paint, and on this fitting some of it immediately chipped off, but this is not a problem because I need to remove all of the paint from this fitting. I think it needs to have a natural brass finish, and because this is an old S50, in the days when they were made from gunmetal, it's going to look quite nice if it all matches. I now need to remove the black paint. Quite a simple job, I've done it many times. I drop the component into a tin lid with some cellulose thinners in it. Cellulose thinners is called lacquer thinner in the USA. I left it like this for a while on the bench. I was working somewhere else. And when I looked at the part about an hour later, most of the paint had disappeared. I just cleaned it up using my polishing spindle. Here is a small bottle of Loctite 542 thread sealant. And I'll be using this stuff as usual on the threads to make sure that everything is steam tight. The next part of the job is to make a threaded sleeve to connect the lubricator to the T-piece. This is a very routine piece of lathe work, and for this I'm using my Myford ML7R. With a suitable piece of 5/16 of an inch diameter brass in the chuck, first of all face across the end. Then using a very small centre drill, I centre the end of it. And by using a centre drill, that will ensure that the hole is in the middle of the bar. The next part of the job is obviously drilling a tapping size hole all the way down the piece of brass you can actually see sticking out of the chuck. The drilling operation started off well as this 7/32 of an inch drill followed the hole made by the centre drill, but then it got difficult. Progress was slow and I was having to apply a lot of pressure to the drill to force it through the work. I think it's time to call the drill doctor. This is a great machine. It's very small, very easy to use and just very convenient. It's a Drill Doctor 750X. I'm not going to go into lots of detail as to how it works. Just watch the image, you'll see roughly how it works. First of all, I clamp the drill with the 2 spring-loaded arms and then tighten the chuck. Then I remove the chuck from that part of the machine and fit it in the hole at the top. All I have to do now is rotate the drill quite gently until the noise stops. Once the noise has stopped, that means that the drill is ground accurately. This machine is very clever, very simple and very adjustable. And in no time at all, the twist drill was sharp once again. And here you can very much see the difference in the performance. The drill tears through the piece of brass. And I'm only gently turning the tailstock hand wheel. In no time at all, it was time to thread the hole 1/4 by 40 threads per inch. I'm threading this part by hand. It didn't take very long, and as you can see here, I've finished the threading operation and I'm rotating the chuck in the opposite direction to unscrew the tap from the hole. I parted off the threaded part of the brass sleeve, turned it round in the chuck, then I tidied up the end with the lathe tool, polished the part, and here I'm fitting it to the engine, using some Loctite 542 to seal the threads. However, on the first attempt I didn't get it right. The sleeve is a little bit too long. I fitted the sleeve back in the chuck of the Myford and turned a very tiny amount off the sleeve so that it screwed further into the T-piece. In the end I decided not to use the PM Research lubricator. It was a bit too big and it just looked wrong. I found this one in my box of lubricators. These lubricators are expensive, they're actually Swiss made, and the last one I bought was from Blackgates Engineering. It's slightly smaller than the Stuart and the PM Research lubricator, but it just looks a little bit better and more in scale on this engine. The lubricator on the Stuart 1010V is a Stuart lubricator, and that looks fine in that application. I need a suitable exhaust outlet. The original hole in the top of the cylinder, in my opinion, is too small on an S50. I've very carefully drilled it out, tapping size for 1/4x40, which, as I've mentioned previously, is 7/32 of an inch. I tried a standard 1/4x40 elbow, but I didn't like the look of it. Instead, I'm going to use a check valve, but most importantly, I do need to remove the ball from the check valve. That's what I'm doing at the moment. This check valve no longer has a stainless steel ball inside it. Now it's just an exhaust manifold. In my head, I've already worked out how the pipe runs are going to be. The pipe diameters will be a mixture of 5/32 and 3/16 of an inch in diameter. The exhaust pipe needs to be slightly bigger on the 1010 because it has 2 cylinders to exhaust. I'll finish this video with the image that I first started with. I think the next job will be to create the pipe runs. I am not going to rub down and varnish the baseboard until right at the end, so I don't scratch the varnish. That's it for this one. The plant is coming on quite nicely now. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.